discuss about test design selection or the best test design techniques. Part 2 of choice the test design techniques. If you remember when we discussed the black box testings, we said that not just only use one technique, you have to use several techniques. Like if you just use boundary value, maybe you just test the boundaries. So maybe this defect in this figure here, it will show this type of defects. Okay, if you use only one type of testing technique, maybe you will find the defects near to the boundaries. Okay, other other defects here, this will not be detected. But if you try to combine, so here you just detect only this defect and the rest will not be detected. Okay, but if you apply many type of test design techniques like boundary value, equivalent partitioning, state coverage, decision coverage, branch coverage, so here by combining testing techniques, several testing techniques, you will be able to cover most of the defects. Okay, maybe some of the defects will not be detected, but it's okay, at least you cover all the defects by combining more than one technique. Okay, so do not just use only one test design technique. So what is a good test case? Who can say this is a good test case, this is a bad test case? Of course, uh, it will be based on several factors or several attributes. The first attribute, that test case is very powerful, can detect the failures or detect the faults. Okay, it also can validate, this case detects real failures. It is relevant, so the test case detects all failures, so it can detect more than one type of failure or defect. Trustworthy, so also can deliver a good results. Representative, it will show how it will be the test case. Not redundant. What mean not redundant? Not repeated. So like we use equivalent partitioning to select one data from each part. So if we just use random, so maybe we select from the same part several data. So it not redundant means not repeated, not the same test cases will be used. Okay, executable. The test case can be run. It is very clear how to use it. Maintainable, I mean, can be repeated, can be maintained, can be adjusted, can be used in the maintenance. So it is adequate of complexity. It is low cost, so it can no need to spend a lot of time to generate test cases. No need tools to generate test cases. It's not costly. Okay, so like that. So for example, here the static uh, statement-based test. So statement-based test only focus on validity because we test each statement, relevance. So it will show this reliability. So in statement testing, if we cover all the statements, it will show that we already execute all the lines in that code or in that function. So the result we get, we will be reliable. It means we'll be safe. Okay. Complexity also less on maintainability. So it will be less during the if we have maintained because you already run all the lines, all the statements. So later during maintenance, of course, because you already discover all the lines, so maintenance will be less. But if we use equivalent partitioning is good because it's not redundant, because we use one value from each part. But it was not reliable because it focused only in one part, in one value, but sometimes will not produce a very good result if the value near to the boundaries. So here it is not focused on representability also and reliability.